Hi guys, I wanted to briefly cover first what is included in the Exam 2 study guide. So any material from Exam 1 shouldn't be a shocker to anyone that we have a lot of fundamental concepts that we discussed for Exam 1 that will be crossing over into Exam 2. Some of these things include being able to look at a research scenario and identify certain variables, classify the data that those variables would fall under. So identifying if you have nominal versus ordinal versus ratio versus interval data, the type of study design or other characteristics of study design, such as the type of sample that you've collected, whether it's between or within subjects. Our fundamentals of statistical inference, where we are kind of looking at how characteristics of our sample might be projected onto a population that sample was drawn from. We also have covered assessments of normality, which are kind of aligned with the assumptions or some of the assumptions that we have for the tests that we looked at for this last section or for modules 4 through 6. We also have covered hypothesis testing more specifically for certain types of statistical tests, with kind of keeping the interpretations of statistical inference for p-values in mind. And then we've also looked at different descriptive statistics, such as measures of central tendency, like the mean, and measures of variability, like the standard deviation, that we can then use to calculate other variables that may be of interest to us, such as effect size, etc., etc. So all of those should kind of not be a shocker. So using that material, we have gone just into a deeper dive on regressions, correlations, and t-tests for modules 4 through 6. And I've outlined some of the formulas that you'll be responsible for that we've covered in our lectures. So they're kind of all just compiled into a single table. All of these are kind of just a copy paste from the different module key terms and concepts. Documents that I usually post on a weekly basis in your review section of your checklist. So any of these are listed in your module PowerPoints, so you can easily track down what the definitions are, or kind of what each of these terms might be referring to for various tests. So that's kind of our terminology section. You will need to be able to calculate a t-statistic to estimate p-values using the t-table. I don't have an example of this in our actual practice questions because I thought there were some other things that I wanted to focus on in the review questions instead of the t-table, since it's pretty simple to use. So if you need to review anything on using the t-table, I suggest looking back at activity 6 for the practice 1 section of the activity, where it goes through how to read the table, as well as how to calculate like the degrees of freedom for both independent and paired t-tests, since they're different, and then how you would look up or estimate the p-value based on a certain level of confidence or alpha level that I give you before you would even consider the level of significance for your test. Additionally, I've listed some concepts that you should know. Again, these are all kind of copied from the key terms and concepts document that I post every week. For SPSS, I will have a note, or I'll try to remember to put a note in your guys' exam about this. But for all tests in SPSS, because the default setting is 95% for your level of confidence, we're going to assume that that is true for all of the outputs that I've given you, which means that the alpha would be assumed to be 0.05. So 0.05 is what you're basing your significance off of for the outputs for at least this practice exam set, and then the same will be true for the test that you take next week. We're also assuming that we have hypotheses for two-tailed tests. So when you're writing hypotheses, like if I ask you to write the null hypothesis, or if you're writing like an interpretation of a p-value, make sure that they're in the format of a two-tailed test or a non-directional hypothesis, so that we're not specifying if we think, like one mean should be greater than another mean, or that, well, I guess the only exception to that would be correlations, because we could say that we either have a significant relationship or no significant relationship, but I did also tell you guys, when you write out if you do have a significant relationship, you can say the direction and the magnitude of the relationship. So if you had like a strong positive relationship, you could say there's a significant strong positive relationship between variable A and variable B. That's fine. For tests that you should be able to run in SPSS, that will pretty much be the scope of tests that we covered in this kind of module set. So we had bivariate and multiple correlations, which is pretty much just running a linear correlation in SPSS and then being able to read the correlation matrix that SPSS gives you, which has an R value and a P value. So you can tell what the direction and strength of your correlation is, as well as if that relationship is significant or not. We also ran bivariate and multiple linear regressions using enter, forward, and backward methods, as well as independent and paired samples t-tests. So these are what you're responsible for knowing how to run as well as interpret for the outputs. And then additionally, I've added kind of a list of the assumptions that are also included in the SPSS analysis. So for multiple and bivariate regressions, you also had to test for independence of observations using the Durbin-Watson statistic. We had to look at collinearity statistics, as well as if we had outliers, specifically for our residuals, as well as if our residuals were normally distributed. And then, oh, I'm sorry, this one is no significant outliers for our ratio variables that we measured. The normal distribution of the residuals is a separate assumption. Sorry, I misspoke there. Then we used different graphs or charts in our output to assess the distribution of the residuals. Then we also had the homoscedasticity scatter plot, where we were trying to see if there was a pattern of our residuals plotted against our predicted values, rather the z-scores of both of those. And then if there wasn't a pattern, then we assumed that we have a homoscedastic data set. For independent t-tests, we also added the homogeneity of variance assumption using Levine's test. And then in our paired samples t-tests, we created a new variable in our data view of our kind of like data set window. And we looked at if we had a normal distribution of different scores that we calculated, as well as if there were any significant outliers of those different scores. So for all of our tests, whether, and I have notes on this in the review questions, but whether you meet your assumptions or not, don't worry about if you have violated something. Usually there's a correction built into the test, and we've looked at different ways to kind of sidestep any violations. But if there are violations, just keep running through the test. It's more of the process that I'm interested in, and less of, if we've met all of our assumptions to like the T, because all of these are sample data sets that I've acquired. So some of them might have issues, but like I said, don't worry about those. Okay, so that's a review of the study guide and what's on it. So feel free to kind of like go back through the lecture notes, fill in different areas, go back through activities if there's certain types of calculations that you don't feel comfortable with or just want to review practice for. I've also posted your Exam 2 review questions. So this models very similarly what an activity would look like. At the beginning, I've given you guys kind of two options to review the different study designs as well as the null hypotheses that are attached to those study designs. So and these were always in the supplemental material, so I don't know if any of you have actually looked at these, but just so you know that they do exist, we have the decision tree, which is kind of useful in helping us decide what tests to use based on variable characteristics. So all of our tests that we've run in this section, as well as all the tests we'll run in our next section for exam 3, have parametric dependent variables. And then the distinctions between correlations and regressions and t-tests were where we had a parametric versus a non-parametric independent variable. Okay, from there, I've listed out assumptions that you would have to have for both correlations and regressions. And then for when we have a non-parametric independent variable, the main distinction of a t-test versus an ANOVA, which we'll cover in exam 3, is the number of levels of your independent variables. So we have a single independent variable, but 2 levels of that variable for t-tests. And if we had a between subject sample, that would indicate we were looking at an independent t-test. If we had a paired sample, or if we had a within subject sample, then we were looking at a paired samples t-test. So this is the filled in flowchart that you can use kind of to check your knowledge. There is a blank one that you can fill in to kind of help you with studying, to make sure that you've kind of understood how we get to certain tests and the different assumptions and study designs that are associated with those. So that's one resource that you can use to fill in. The other resource that I have for you guys is the stat summaries, which pretty much do the same thing, where they're outlining what the assumptions are. A lot of these are more or less based on study design characteristics. I've also pulled out those study design characteristics, so you're saying how many dependent variables, the type of data that they should be, the number of independent variables, the number and the type of data they should be. At the bottom of the table, I've also added the null hypothesis for the main test. So we've seen several different p-values, especially in regressions. There's a lot of p-values. So making sure that you understand what the main point of like a regression versus like the main point of a t-test is, that's what this section is for. Okay. So like correlations, we're looking at the p-value for R when we were trying to see, is there a significant relationship between variables or not? The p-value for F in the ANOVA table is kind of like our main assessment of how well our model worked, predicting a certain dependent variable given its relationship with a number of independent variables. And then for our t-test, we were just mainly interested in if there was an effect of the independent variable on the dependent variable, and another way we worded this is if there is a significant difference between the means or not, right? In all cases, the null hypothesis is always going to argue that we have no relationship, no significant predictors, or no significant effect. And I just noticed, or not, that should be there. The other thing I wanted to point out in here is that the assumptions that have kind of like p-values attached to them, you want to know how to test and interpret those in SPSS. The other ones that would be included are these ones, so I can make those yellow as well. Okay. So I do have a blank version of this posted in Beachboard as well. So again, you can use either the flowchart or the stat summaries to help you study. I know people like to study differently. Some people resonate with tables versus people who resonate with pictures and flowcharts. So use the method that works best for you. On the exam 2 review, I have it that you can fill out both of them, but see which one works better and then just stick with that method. So that will kind of bring us into our research scenarios, which I'm going to do in the next video.